Good evening, students. Let us continue up with the MCQs of semiconductors, electronic devices. In the last session, we have explained the concept of the band theory and the classification of solids and also the types of semiconductors. Now, in the today's session, let me have the concepts discussion on semiconductor diode and the logic gates. Yes, I said this is completely a theory oriented chapter, students. So let me have some discussion on theory concepts. Yeah, look at the first question. In the forward bias, what will happen? You know that if the PN junction is there, if I say this is P type and this is N type, P type is connected to positive terminal and N type is connected to negative terminal. This is said to be a forward bias. P type should be connected to positive terminal and N type is connected to negative terminal, which is not connected. So anyway, only one terminal they are talking. P type should be connected to the positive terminal. N should not connect to the positive terminal. Direction of current is from N to P type? No, P to N. P is connected to negative terminal? No. In the forward bias, P end is connected to positive terminal. So option B is the right answer. So in the PN junction diode, choose the correct statement here. Current in the reverse bias condition is generally very small. Yes, because in the reverse bias, there will be no conduction of current. Current is very, very less. It is of order almost 10 power minus 6 ampere, microampere, which is almost a negligible value. So in the case of the reverse bias, the current is very, very small. You know what is the cut-in voltage for silicon diode? Yes, it is called 0.6 volt. For germanium, it is approximately 1.1 electron volt. The electrical circuit, to get the smooth DC, the circuit is what we called as the filter. So if you use the filter in the circuit, we are going to get a smooth DC source. In order to get the smooth DC, we have to connect a filter in the circuit. So in the case of a PN junction diode, as an insulator, what will happen? If PN junction is going to work like an insulator, in insulator, there will be no current, current will be zero. Therefore, it is said to be in a reverse bias. So current is almost negligible. It is almost less only in the case of reverse bias. So option C is the right answer. And in the case of a reverse bias, what will happen to the potential barrier? Potential barrier increases no in the reverse bias. Because if I connect a PN junction diode like this is P type, this is N type, this is depletion region. In the reverse bias, this P type is connected to negative terminal, N type is connected to the positive terminal. And whatever the volts are there here, these volts will move towards the negative plate, and the electrons which are there here, that will move towards the positive plate. So this depletion region will increases. So there is an increase in the potential barrier. Therefore, option B is the right answer. So electrical resistance of the depletion layer is large. What happens? If electrical resistance is very large means, can you conclude the current is almost zero? Because resistance is the opposition for the flow of current. If resistance is more, current will be zero. If the current is zero, actually there will be no charge carriers. If there are no charge carriers, then only you are going to get the current as zero. Therefore, there will be no charge carriers if the electrical resistance is large. Please remember that. Yeah. Now, there is a circuit here. What is the value of the current? Now, you know that by Ohm's law, current is defined as the potential drop divided by the potential of drop divided by the resistance. Now, here it is 4 volt and here it is 1 volt. So, potential drop is 4 minus 1 divided by the resistance what we are using in the two terminals, that is 300 ohm. This is nothing but 3 by 300, which is nothing but 1 by 100. 1 by 100 is nothing but 10 power minus 2. So option B is the right answer. So 10 power minus 2 ampere. So let us skip the next problem because the circuit is missing here in this problem. Yeah. In the forward voltage, in the case of the semiconductor diode is doubled. What happens to the width of the depletion region? You know that as the applied voltage is increased, in the case of a forward bias, this depletion region will decreases. If the forward bias voltage is doubled, the width of the depletion region becomes off of the voltage. Because this voltage which is applied, only 50% is going to work on that. The other 50% there will be an opposition. So only 50% is utilized for the average. So only half of that it is going to become. So width will become off if the forward voltage becomes double. The PN junction diode is used as what? You know that the PN junction diode is going to be used as a rectifier, which is going to convert AC into DC. So rectifier is a device which converts AC into DC. So PN junction diode is going to be used as the rectifier. When a PN junction diode is reverse biased, you know that in the case of a reverse biased, the depletion region is going to increase. Why the depletion region will increase? Because the volts will move towards this positive terminal, electron will move towards this side. So the volts and electrons will increase. It will move away. When the volts and electrons are going to move away, can you tell me what happens to the width of the depletion region? Width of the depletion region will increases. So electrons and volts will move away from each other and depletion region actually will increases. That is in the case of which bias? Reverse bias. There are two PN junction that is connected as shown in this diagram. The potential difference in the junction is same. Then you have to tell which is the correct connections. Look at the diagram. They are telling it is connected in series. It is connected in series. Yeah, here they have given the circuit 10. 1, 2, 3. Series means if I say this is positive negative, the next thing should be positive negative. positive end should be connected to negative. If the same connected, then it is said to be parallel. So look at here, N and N are connected, same ends. So this is parallel. First circuit is parallel. Second one, look at this, N to P is connected. So it is said to be connected in series. Here P is connected to N. So this is also said to be connected in series. So circuit 2 and circuit 3 are in series. The first circuit are in parallel. So 2 and 3 are in series. The circuit 2 and 3 are in series. There is a PN junction. Can you tell me the thickness of the order? The thickness of the junction is 10 power minus 6 meter. The thickness of the PN junction diode is 10 power minus 6 meter. In the depletion region of an unbiased PN junction diode, in an unbiased means no external source is connected. When no external source is connected, there will be no electrons or holes. There will be only fixed ions. After connecting the external source, then only there will be a creation of the positive charge carrier and negative charge carrier, that is holes and free electrons. So in the case of the depletion region, there will be only fixed ions if it is unbiased, if no external source is connected. On increasing the reverse bias to a large value in PN junction diode, current suddenly increases. Have you observed? If I plot the voltage and the current in the reverse bias, up to certain voltage, the current remains same. At one particular breakdown voltage, the current gradually becomes maximum. The current gradually becomes maximum. So suddenly increases. So in the case of a forward biasing, which one of the following figure correctly depreciates the direction of the flow of carriers? See here, for the forward bias, first of all, P should be connected to positive terminal, N should be connected to negative terminal. All the cases are there. Now, towards the P type, N should move. Towards the N side, the volts is going to move towards that. Look at the diagram, which is going to be the right option. Look at this. In the circuit B, C, and D, all electrons are moving towards the hole and all positive are moving towards the negative type, which is not possible. Because in the depletion region, all electrons will combine towards the positive charge and negative charge will move towards the N type. So only option A is different from B, C, D. Because B, C, D are same, which is not possible. So option A represents the flow of what? The direction of the current. Because the current has to flow from P to N, it is moving from negative to positive side. Because all options, all diagrams are going to be the same. All diagrams. So, similar case. A, B, C, D, all are correct. Which of the following statements concerning the depletion zone of an unbiased PN junction is true? Unbiased. Unbiased means the external source is not connected for this depletion region. If external source is not connected, the width of the depletion region will not change. So there will be an dopants only because of the electric field which is going to exist, and also the width of the zone is dependent on the density of the dopants. So if the dopants are more, then the width will be more. So your two options are correct, that is B and C. Yeah. There is a semiconductor device that is connected in series circuit with a battery and resistance. Look at this series. A current is found to pass through the circuit and polarity of the battery is reversed. Then the current drops almost to zero. Then the device may be what? It should be a PN junction, no? Because if I say this is depletion region, this is P type, this is N type. P type is connected to positive terminal, N type is connected to negative terminal. Now, initially, if P type is connected to positive terminal, there will be a flow of current. Suppose if the polarity is reversed, by making this as negative, this as positive, then this will become a reverse bias. If this becomes a reverse bias, the current has to come to zero, no? So when the current comes to zero, when the polarity is interchanged, means this circuit will act like what? A diode. Diode means what? A PN junction. What is the approximate ratio of the resistance from forward to reverse bias? Resistance of forward to the resistance of reverse bias is almost 1:10⁴. Because in the forward resistance, the opposition will be less. In the reverse bias, the resistance will be both. So the ratio will be almost 1:10⁴. So in a junction diode, the volts are due to the missing of electrons. Why the volts are created? If the electron leaves from the covalent bond, when the covalent bond breaks, the electrons will come out from the bond. So there will be a vacancy created there. That vacant position is called as the hole. So hole is created because of the missing of electron. In forward bias, what happens to the width of the depletion region? Decreases. Width of the depletion region decreases in the case of a forward bias. The cause of the potential barrier in the PN diode is the potential barrier in the PN junction is because of the concentration of positive and negative charges carriers near the junction. In the potential barrier, there will be a recombination of volts and electrons, right? In the midway, that concentration of positive and negative charge near the junction is what we considered as the potential barrier. So if the PN junction diode is not connected to any circuit, if it is not connected to any circuit means there will be no external source. There will be no external source. So there is an electric field at the junction which is directing from N type to P type. If there is no external source, electric field at the junction will direct from N type to P type, because electric field is going to move from negative terminal to positive terminal. So option C is the right answer. Which of the following statements is not true? Resistance of intrinsic semiconductor decreases with increase in temperature? Correct. Since it is a semiconductor, resistance is inversely proportional to temperature. So as temperature increases, the resistance will decreases. What happened? Huh? Doping pure silicon with a trivalent impurities gives p-type semiconductor. Silicon with a trivalent. Correct, no? Trivalent means there will be only 3 electrons will be there. There will be one shortage of electron. So there will be a hole is going to create. So it becomes a p-type semiconductor. This is also true. The majority charge carriers in N-type semiconductors are holes? No, this is wrong statement, right? Because for the N-type semiconductor, the majority charge carrier will be free electrons, but they are telling holes. So not possible. So this is the wrong statement. Okay. The dominant mechanism. The dominant mechanisms for the motion of charge carriers. The dominant mechanism for the motion of charge carriers in forward and reverse biased silicon PN junctions are: there will be a diffusion of charges in forward bias and drift in the reverse bias. Because in the reverse bias, it will not constitute. We have to give the external agency to drift the charge carriers. So in the reverse bias, there will be a drift. In the forward bias, there will be a diffusion. So in the PN junction, avalanche current flows in the circuit in the case of reverse bias. The depletion region in the case of a PN junction region is caused due to the diffusion of charge carriers. Charge carriers is having both holes and free electrons. Yeah. Which one is reverse biased? You know that in the case of a reverse bias, p-type should be connected to negative terminal. N-type should be connected to a positive terminal. Negative means low, positive means high. So this positive is connected to plus 15, negative is connected to 10, so it is forward. P is connected to minus 5, N is connected to minus 10, minus 5 is much greater than minus 10, So this is also forward bias. P-type is connected to -10. N-type is connected to 0. 0 is more compared to -10. So negative is connected to higher voltage means this is a reverse bias. So option C is the right answer. So in the PN junction diode, P region is heavily doped. P region is heavily doped than the N region. Then the depletion region is greater in N region. If you don't dope, the charge carriers will be there. So there will be a depletion region is greater in N region. So which one of the diagram is in the forward bias? This is nowhere connected to source. So this is unbiased. This positive is connected to positive terminal. N is negative is connected to negative terminal. So this is in forward bias. P is connected to negative terminal. So it should be in reverse bias. None of this. So the second option, the second circuit is in forward bias. The reason of current flowing in the PN junction in forward bias. As I said, in the forward bias, there will be a diffusion of charge carriers. Drifting will come in the case of reverse bias. Since it is a forward bias, the current will flow in the PN junction because of the diffusion of charge carriers. Because of the diffusion of charge carriers. The resistance of the reverse biased PN junction diode is about 10 power 6 ohm, close to 10 power 4 ohm. It is close to that, either 10 power 4 or 10 power 6 ohm. Now, you consider the two statements. One is the statement A and the another statement is B. You have to identify the correct choice of the given answer. The width of the depletion layer in the PN junction diode increases in the forward bias? No. In the forward bias, I mean false. Because in the case of a forward bias, the holes and electrons will recombine. It will constitute the current, and at one particular voltage, which you considered as a cut-in voltage, at that voltage, the depletion region will break and there will be a flow of current. So what you can tell? The statement A is false. Actually, the depletion region decreases if in the case of forward bias. Look at the second statement. In an intrinsic semiconductor, Fermi energy level is exactly in the middle of the forbidden gap. Correct? No? Correct. Because it is an intrinsic pure, so it is exactly lies in the middle. Suppose if it is doped, the Fermi energy level may lightly downward or upward towards the valence band or that towards the conduction band. So A is false, B is true. So option C is the right answer. in comparison to a off wave rectifier. In comparison to a off wave rectifier, the full wave rectifier gives lower. No, full wave is always going to be more than off wave comparatively. So efficiency is more, average DC will be more, even average output voltage is also more. So option D is the right answer. In the case of a full wave rectifier, all the output efficiency will be more compared to the off wave rectifier. Avalanche breakdown is due to what? Avalanche breakdown is due to the collision of the minority charge carriers. Because avalanche breakdown will come into picture in the case of a reverse bias. So in the reverse bias, there will be a minority charge carriers. Yeah, can you choose that reverse bias? See here, this is P, this is N. P is connected to -20, N is connected to -10. So -10 is more compared to -20. This is at high voltage, this is at low voltage. So P type is connected to lower voltage, N type is connected to higher voltage. Therefore, this bias is going to be a reverse bias. Zener breakdown in the semiconductor diode will occur in the reverse bias exceeding certain value. You know that Zener diode will work only in the case of reverse bias, and definitely it will break only certain exceed value. That is what we considered as the Zener diode voltage. When forward bias is applied, what happens to the potential barrier? Potential barrier will decrease, right? Because in the forward bias, there will be a combination of holes and free electrons. So the width of the depletion region start decreasing. So the potential barrier will decreases. And the width of the charge in the depletion is also decreases, because in the forward bias, there will be a recombination and it constitutes current. So both potential barrier and the width of the depletion region will decreases. So option D is the right answer. The potential barrier in the depletion layer is due to because of ions. There will be immobile ions, no? Because in the depletion region, it is the region where the mobile charge carrier will become a immobile ions. So option A is the right answer. I think you can search for the diode which is forward bias. This is P type is connected to 0, N type is connected to higher voltage. So definitely this is reverse bias. Negative is connected to lower voltage, positive is connected to higher voltage. So this is forward bias. Third one, this is 0, this is -10. So this is high voltage. N, this is connected to high voltage. So this is reverse bias. N type is connected to -12. P type is connected to -5. -5 is much more compared to -12. So this is forward bias. This is connected to 0, which is higher voltage. -10 is low voltage. Negative is connected to low voltage. So this is also forward. So the second circuit, the fourth circuit, the fifth circuit. The second circuit, third circuit, fifth circuit. All these three circuits are in forward bias. So 2, 3, 5 are in, this is 4, 1, no? So 2, 4, 5 are in, this is the third one. 2, 4, 5 are in the forward bias. The first circuit and the third circuit are in the reverse bias. So 2, 4, 5 are in the forward bias. Now you know that what is the function of the rectifier? Mainly the rectifier is used to convert AC into DC. And also you know that there will be two types of rectifiers. One is off wave rectifier. The second one is the full wave rectifier. When P end is connected to the PN junction is connected to the negative terminal. N end is connected to the positive terminal. Ulta, P is connected to negative terminal. So when P is connected to the negative terminal means it should be connected in the reverse bias. You know that in the case of a reverse bias, the current constitute will be 0. Therefore, definitely it will act like an insulator. It will act like an insulator. If the two ends P and N of a PN junction diode are joined by a wire, what will happen? If you just connected by a wire, there will be a steady current flow will not take place because it is a diode, which is no current is going to constitute. There will be no steady current in the case of the circuit because of the junction. Potential barrier of 0.50 volt. Potential barrier is 0.5 volt. Depletion region width is 5 into 10 power minus 7 meter. What is the intensity of the electric field? You know the relation between electric field, potential and the distance. E is equal to the potential divided by potential is 0.5. Length is how much? 5 into 10 power minus 7. 0.5 by 1 is 0.1. 0.1 into 10 power 7. 0.1 into 10 power 7. Or you can take 1 into 10 power 6. Option A is the right answer. If no external voltage is applied across the PN junction, there would be an electric field pointing from where to where? P to N type. Option B. I think the same type of question we have studied. We have seen in the before questions. You know that in the PN junction, high potential should be at N side, low potential should be at P side. Look at the diagram. This is P type, this is N type. P type is connected to positive terminal. N type is connected to negative terminal. So definitely it should be a forward bias. So these two are ruled out. So forward bias voltage should be V. It should not to be. The voltage should be V. So on adjusting the PN junction diode, the forward bias, what will happen? In the case of a forward bias, depletion region will increases? No. Resistance will increases? No. Because it is a forward bias. In forward bias, the depletion region will decrease. Even the resistance also will decrease. So both are going to decrease. So on adjusting the PN junction diode, in the case of a forward bias, the depletion region and the resistance will decreases. So both are going to be decreases. In the middle of the depletion layer of the reverse bias, electric field is maximum. Please remember. Barrier potential will not depend on the diode design. The crystal diode is a non-linear device because it doesn't Ohm's law, it doesn't obey Ohm's law. You know that the voltage versus current, if I plot, it is going to be like this. I think this you can manage. You have to search for reverse bias. How to search it for reverse bias? P type is connected to -5. N type is connected to -12. -5 is more. So this is forward bias. P type is connected to 0. N type is connected to -10. So this is higher compared to minus. So this is also forward. This negative is connected to +5. Positive is connected to +10 means this is also forward bias. This is 0 volt because it is grounded. If P type is connected to 0 volt means, and this negative is connected to +5 volt means this is at higher voltage. So this should be a reverse bias. It is connected reverse. In the PN junction photocell, the value of the electromotive force of the monochromatic light, you know that it depends on the intensity of the cell. So whatever the EMF is there, EMF is directly proportional to current. Current is directly proportional to the intensity. So option C will be the right answer. Which is the correct diagram for the off-wave rectifier? Two diodes we are not going to use. And for the input, we cannot use capacitors. If you use the capacitor, it will block what? Current. So we are not using this. Across the output, we are using this capacitor. So the correct diagram for the off-wave rectifier will be the second one. You know the maximum efficiency for the full-wave rectifier is 81.2%. For off-wave rectifier, it is 40.6% for off-wave. For full-wave, it is 81.2. What is the serious drawback of the semiconductor? Yes, it cannot withstand with high voltage. Because you know that for germanium, the highest voltage it can withstand is 1.1 electron volt. For silicon, it is 0.6 or 0.7 volt. So silicon can withstand only up to 0.6 to 0.7 volt. For germanium, maximum is about 1.1 electron volt. So they cannot be used with the high voltage for the semiconductor. So that is one of the major drawback. Select the correct statement. In the full-wave rectifier, two diodes are going to work alternatively. Yes, because in the case of a full-wave rectifier, for the first off cycle, the diode D1 is going to work. The second off cycle, the D2 is going to work. Meanwhile, the diode D1 becomes for reverse bias. In order to have forward bias PN junction, negative terminal should be connected to N side. For forward bias, P type should be connected to P side. N type must be connected to N side. So option C is the right answer. They have given that diode. They are asking what is the potential difference between A and B across this. What is the voltage we have applied here? 6 volt. Since there will be some voltage drop here and the diode is going to take maximum voltage, so you can tell whatever the applied voltage is there, it is going to be used in this, because this is connected in the case of reverse bias. Because P type is connected to negative terminal, N type is connected to the positive terminal. So in the reverse bias, the current will be 0. This will becomes no effect. So whatever the voltage we have applied here, 6 volt, it should be connected across the diode, because there will be no current across the 2 ohm resistor. Since the diode is in reverse bias, there will be no flow of current in the 2 ohm resistor. Therefore, whatever the voltage drop is there across 2 ohm, the voltage drop across the 2 ohm is also 0, because current is 0. Since the voltage drop across this is 0, whatever the applied voltage we have given, that is 6 volt, that is taken to the diode itself. So this is the 6 volt. So option A will be the right answer. Zener breakdown takes place only if the impurity, doped impurity is very high. Because what is the special characteristics of the Zener diode? Zener diode is basically meant to work for the reverse bias and which is very, very highly doped. So for the Zener diode, the doped impurity must be very high. So you consider the two statements, one is A and the B. Zener diode is always connected in reverse bias. Yes, it is true statement. What is the potential barrier of the PN junction diode lies between 0.1 to 0.3? No. Even for silicon, it lies from 1.1 electron volt energy, or potential is 1.1 volt. So it cannot lie between 1.1 to 0.3. It lies from 0.1 to 1.1 volt. So option B is false. So A is correct, B is wrong. Option C is the right answer. Which is the correct symbol of the Zener diode? This is normal diode, this is battery, this is not a symbolic representation. The correct symbol of the Zener diode is this. Which one of the following statement is not correct? Diode does not obey Ohm's law? Yes, it doesn't obey Ohm's law. PN junction diode symbol shows the arrow indicating the direction of the current? Yes. Ideal diode is like an open switch? Howdo? Yes. Ideal diode, where the current flows continuously, there will be no opposition at all. So it cannot be used as a switch. Transistor is going to be used as a switch. So diode cannot be used as a switch. This is the wrong statement. I hope you can manage with the 65th problem, because almost many problems we have solved like this. Almost 3 to 4 types we have solved. Just you find which is the reverse bias. For reverse bias, P type should be connected to the lower potential, N type should be connected to the higher potential. No bias means unbiased. In the unbiased, there will be no current, no electrons, or no volts. There will be no charge carriers in the case of unbiased. Zener diode is going to be used as voltage stabilizer, or you can say it is going to be used as a voltage regulator. This is the width of the forbidden energy gap. You have to ask the Fermi energy level. off of that. So it is lesser than 0.5 electron volt off of that average. Symbolic representation of the diode, photodiode. This is the photodiode which works in the reverse bias. We have to incident the light energy. So when the radiation is incident on the diode, the charge carriers are going to create by absorbing the energy. So this is the symbolic representation of the photodiode. Look at the circuit. Can you tell me which will be the circuit? When you apply the voltage in the case of A and C, this is positive. This is diode D1. This is diode D2. For positive type, this D1 will become forward bias, but D2 will not conduct. Coming to this side, negative terminal, this P is connected to negative, so this is reverse bias, but this negative is connected to negative, this will become forward bias. So once for the first off cycle, if D1 is conducting, for the next off cycle, this D3 is going to conduct. So in both the cycles, if D1 is conducting, for the next off cycle, D3 will conduct. So in both the cycle, the diode is going to work. Therefore, we can consider it as a full wave rectifier. What is the current flowing through the ideal PN junction in the circuit? If this P is connected to 0 volt and this N is connected to the 0 volt, what will happen? Both the ends will be at the same potential. So no potential difference across the ends. Therefore, there will be no flow of current in the circuit. So option A, 0 current. There is a diode. Diode is having a potential difference of 0.5 volt. And that doesn't depend on the current. And the series resistance is there, that is 20 ohm, that is RS. Current is there, that is 0.1 ampere, which is passing through the resistance. What is the voltage source? Be very careful. There is a diode. This junction diode is 0.5 volt. This is connected to some voltage. There is a forward resistance. What is the forward resistance? 20 ohm. Now there is a current of 0.1 ampere here. Now they are asking you to find what is the voltage source, this voltage. Yeah. When 0.1 current flows here, the same 0.1 current will flow in the resistance. Then across this resistance, can you find the voltage drop? How to find the voltage drop across the resistance? Voltage drop across the resistance is V is equal to I into R. Current is 0.1. Resistance is 20. So there will be a 2 volt. So the potential drop across the resistance is 2 volt. Potential drop across the resistance is 2 volt. Then what is the voltage drop across the diode? It is 0.5 volt. Here we have 2 volt. Here we have 0.5 volt. Therefore, what is the total voltage across the circuit? It is 2 volt plus 0.5 volt. So together it is 2.5 voltage. So option C is the right answer. So what is the total voltage drop in the circuit? Across the given resistance which you connecting in series, that is connected with 20 ohm resistance, right? Across that we are getting a voltage of 2 volt. Across the diode, we are getting 0.5 volt. So what is the total voltage across the circuit means 2 volt plus 0.5 volt. So it is 2.5 volt. So option C is the right answer. Got it? Yeah. Oh, this is logic gates. We can take up this logic gates in the next session, students. So in the next session, we'll discuss the concept of logic gates, and we'll left out with only one small another chapter, that is electromagnetic waves. I can discuss that electromagnetic waves in one session and this logic gate in next session. So altogether, almost in another 2 sessions, I will finish it off this. Then we can go with the previous year NEET paper discussion in the classes. Is it fine? Okay, I will stop at this stage. We'll continue in the next session. Thank you.